So as they watched in horror, Jamal had a cupcake, and Dina, she had a sandwich. And they both hit Harold in the head. Right? And so they give us kind of some dimensions because they talk about the path in which the cupcake and the sandwich flew across the room to hit poor Harold in the head. And so they want us to start off by drawing like a picture representation of what's going on with our cupcake and with our sandwich. Sound good? So let's talk about our cupcake. Right. Anybody got any ideas on how this cupcake went flying through the air? What shape it might have looked like? Like it slipped out of their hand and it went up. Yeah, made an arch, right? What goes up must come down, right? So I bet you, making it looking perfect, right? It's gonna go up and it's gonna come down. Anybody know what that shape's called? Starts with a P? That's a parabola, right? And a parabola is a quadratic. So we're going to throw some x and y axes on here. Hey, good job, parabola. Yeah, unmute yourself. It makes it a little easier and faster. We got to hear it. So we're going to draw some x and y axes. So we're going to act like this was our ground, right? And this is our y, so it's kind of like our height type of thing. And so they gave us some dimensions, and I bet you there's some points we can figure out. So we know points are just our x, y coordinates. So we can name this point, right, where it'd be like at the origin. What's the x, y coordinate there? 0, 0, right? And if we go through, what does it say? The cupcake flew on a path that would have landed 20 feet away from him. So where would we put 20 feet away from him? Where would that go? Would it be up here? Or would it be over here somewhere? On the x-axis, yep. So it's going to be 20 feet away. So this would be where it landed on the ground, right? 20 feet away. So we can name that point. What would the coordinates for that point be? Yeah, 20, 0, right? It was 20 feet horizontally, right, across. And it didn't go up or down any because that's where it hit the ground, right? So if it's on the ground, because remember they hit the ground first and then it flew out of their hands and then it landed back on the ground. So it's not up in the air, it's not levitating or anything, so it would be at 0. And last semester, and in the last chapter, and even the chapter before that, when we talked about parabolas, we said that all parabolas were, it starts with an S, I forget the word. Oh, that was it, yeah, symmetric, right? And they're symmetric around that little point called the vertex. Right? And that vertex is just that turning point. So we were going up, we were going up, we were going up until we got to a point, and then we started coming down, right? So that's where our vertex is. And symmetric, or having symmetry, it's the same on one side as it is on the other side. So I bet you we could figure out our x-coordinate for that vertex. Anybody want to take a guess at it? 10, right? It'd be 10 to the left and 10 to the right, which got us to our 20. So that's going to give us our 10. So now we just got to figure out the y-coordinate, and the y has to do with how high it is. So if we go back to our little problem, and we're talking about the cupcake, does it say anything about the cupcake? The cupcake flew 10 feet high. So it went up to up to 9 feet, and then it fell. So our y-coordinate's going to be 9. I think that's a good little picture of what happened with our cupcake, right? So ultimately, in the end of this, they want us to figure out how tall Harold is. And ultimately, when it came to this cupcake and the sandwich, both the cupcake and sandwich did what to Howard? it hit him in the head, right? And we can almost think of our head as being like a point. So here comes the cupcake and here comes the sandwich, and they both hit at the same spot. So they almost are like they intersected each other, right? So if we can figure out the equation to both of these parabolas and find out where they intersect, we could figure out how high or how tall Harold actually is. So we need to come up with an equation for our parabola. You guys remember how to find equations of parabolas? You guys are excited. So since we have it in graph, we have a graph of it, we might as well use that graphing form or that vertex form because we see the graph, we know the vertex. So that was what? Y equals a x minus h squared plus k, right? And up to this point, we've been able to figure out our vertex, and when it came to our a, we always knew if our a was positive or negative, right? And on this graph, our a is going to be positive or negative? It's going to be negative, right? If it was upside down, right? Or if it had a maximum point, it was negative. But we kind of left a alone for you guys, other than, you know, is it compressing it or is it stretching it? So now we finally get to, and I know you guys have been waiting for this moment for a very, very long time. You have been just dying to figure out how to find out a, right? So we now get to figure out how we actually find out a when it comes to our equations. So in our graphing form, our h and our k, that was our vertex, right? So this is our h and this is our k. And then we have this x and these y's. So when I make that parabola, how do I make a parabola? What's it made up of? It's made up of a whole bunch of points, right? So it's made up of a whole bunch of x, y coordinates in order to make that graph. So granted, when we write out the equation when we're done, we don't fill in the x and the y because we want to be able to represent all of the points that are on the graph. But we can pick any point on the graph and plug it into that equation and it would work out. So we can just go through and we can pick out a point and we can put a point into our equation for x and y. And then when it comes to our equation, we have everything filled in except for a, so we can solve it for a. The only thing is when we put in x and y, we can't use the vertex because we already used the vertex for h and k, right? So that's just the only point we can't use. So I don't know. Let's go for poops and giggles and put in 20, 0. And make this our, whoops. Make this our x and our y, right? So I'm going to slide it up a little bit for us. So what am I going to put in for y? 0. Yeah. What am I going to put in for a? A, because that's what I'm looking for. Right? What do I want to put in for x? 20. Oops. Minus our h, which is? Yep. That whole thing is squared. Plus our k, which is? 9. Right? So now we're just going to do a little simplification, right? Do some algebra. So what do we get? 0 equals, we can try and do a couple steps together. 20 minus 10 is 10. 10 squared is 100, right? So that would be 100a plus 9. What do we want to get all by itself? A, right? So what are we going to do? Subtract 9 from both sides. And last but not least, we're going to divide by 100, right? And we can't reduce our fraction, so we're good with that. So now we have our a. So now we can go back to our equation, and then we can fill in our a, our h, and our k, and just have our x's and our y's, right? So what do we have? Y equals negative 9 over 100. And then x minus 10 squared plus 9. I really thought I could fit that all in there. I'm going to go for it one more time. How about y equals negative 9 over 100 x, whoops, minus 10 squared plus 9. You guys good with that one? All right. So we figured it out for the cupcake. So guess what we got to do now? Figure it out for the sandwich. Yep. And I feel bad for the cupcake. Like if my cupcake went flying and hit the floor, I would not be happy. The sandwich, I'll let the sandwich go, but the cupcake, come on. All right. So same little thing. What's our shape going to look like? Yep, it's going to give us that little parabola. All right. We know that our sandwich went how far? Yep, 24 feet. So that would be the point 24, 0. Bless you. If you want, you can throw in the 0, 0 for the origin. And then now we just need to figure out our vertex. So our x is going to be 12. And our y is going to be 6. Yep. Or our k, since it's actually the vertex, right? So we're still going to use that same formula, y equals ax minus h squared plus k. Yes? Yes. Yep. So what do we want to put in for y? 0. We're looking for a, so we're going to leave our a. For x, we're going to go with what? 24 minus 12 squared plus 6. 24 minus 12 is 12 squared is? You guys are on fire today. Yep. And then plus 6, right? So we're going to subtract 6, divide by 144. And I bet you that's going to reduce, whoops, I'm going to slide that up. Sorry, guys. Negative 6 goes into 6 once, 6 goes into 144 24 times equals a. So my equation is going to be what? Y equals, my a is negative 1 over 24 x minus 12 squared plus 6. Right? And then we can always kind of do a couple little double checks on this, right? Making sure that our a is negative because it's opening downward. And then we can check to see if our vertex is put in there properly, right? All right, so we said a little bit ago, like when it came to this, so now that we have our two equations, because they both hit them in the head, so both of those trajectories of those graphs actually intersected each other, and they intersected on his head, right? So in order to figure out that intersection point, what do you think you're going to do with these two equations? Set them equal to each other, right? So you would have, what is it, negative 9 over 100 x minus 10 squared plus 9. And that guy is going to equal our other one, which was negative 1 over 24 x minus 12 squared plus 6. Right. And then now you got to ask yourself the question, do I want to solve this algebraically or do I want to try and graph this? What do you think? Something that's wild and crazy like this, I'm going to say we're going to try and graph these two, right? So we're going to hop on over to our Desmos app, right? So you guys got to help me out, make sure I'm putting in these equations the right way. So what do we got? Negative 9 over 100. X minus 10, that whole thing was squared, plus 9. Right? So we got this little guy going on. So when it comes to graphing, and especially when it comes to using a graphing application, like this whole entire graph doesn't make sense. Because remember how our x-axis is our ground? So all of this stuff down going this way, whoops, and going from all this stuff going this way, where's all of that technically at in the real world? That would be under the ground, right? And is our cupcake gonna ever go under the ground after we throw it? No, right? So this is just where when it comes to, like, sometimes when they ask you questions like which graph fits this situation, we got to kind of think of it in the context in which they give us the problem. So on this one, we're talking about throwing something. So we know then that the bottoms we're not going to look at. We're just looking at the part that is above, right? And we started at 0, 0. Our cupcake landed 20 feet away. Right, and it was 9 feet up in the air when it hit Howard in the head. So then now we got to do our second one. Negative 1 over 24. This thing doesn't like my regular x's. X minus 12. That guy was squared plus 6. Is that the right one? Right. So the same thing. We're going to ignore all of our negative y's because we're not going into the ground. And so if we threw the sandwich didn't quite go as high, but then it sat there and it came down. But where's Howard?
Where they intersect.
Howard is where they intersect, right? So he's right there. So now we have to figure out, since we're talking about how high or how tall Harold is, do we want the x coordinate or do we want the y coordinate? Yeah, well, I'm asking you why because we need to know which one. Come on, guys, that was a joke. Thank you for laughing. Extra credit. Yep. Yeah, because we're talking about how high somebody is, so we're looking for that height. So height is going to go up and down or vertical, so we're looking for the height. Now, if they asked how far away is Howard, Howard was approximately how many feet away from them? 16.5 feet away from him, right? So that thing went flying. So now we just need to be careful. So we're just going to go with, 5.14? You guys good with 5.14? Right. So we got to talk about that 5.14 real quick. So we knew we were at 5.14 feet, right? Because we were talking about in feet. So when I figure this out either like on my calculator or when I look at my graph and I get that 5.14, does that mean it's 5 feet and 1 inch? Or what's the 1 for? Do you think that's telling you exactly how many inches? Yeah, trick question, huh? So being in the lovely United States that we are, our feet are not in a base 10 system, right? We don't get to like 10 feet and then, or 10 inches and then get to a foot, and then 20 inches is 2 feet, that type of thing, right? Our feet are how long? They're 12 inches, right? So that 0.14 is actually like 14 hundredths of a foot, right? Or it's like 14% of a foot. So we actually have to convert that into inches if it asks for feet and inches. So this gives us our feet, right? So he is 5 feet. But in order to turn this one into inches, we got to multiply it by, we got to make that conversion. So that 0.14 times how many inches in a foot? 12, right? And then our fancy dancy calculator, 0.14 times 12 gives us, we're going to round it to 2. So he's actually, 5 feet and 2 inches tall. How's that? Right. Not too shabs? All right. So I think the theme for today is talking about food and looking at food. Because the second problem they give us is we're going to actually do a little candy fundraiser. You guys ready to go get ready for a field trip? So in order to go on a field trip, we got to raise some money. So problem 48, they want us to now write another system of equations. So we got to come up with the equation that's going to fit this situation. And then we're going to have to solve it for our system. So our math class wants to collect money for a field trip. So it decides to sell 2 kinds of bags of candy. So there's the chocolate lover bag, and the chocolate lover bag costs $4.25. And you get 5 chocolate truffles and 2 caramel truffles. Right? Is it caramel or is it caramel?
I say caramel.
Caramel? Caramel. Any caramels in here? Alrighty. And then we're also selling a combusting caramel bag, which is going to cost us $3.50. And in there you get 8 caramel truffles and only 2 chocolate truffles. So they want us to come up with a system that represents both of those scenarios, and then we need to solve it to see how much a chocolate. We got to get some variables on here. So we have 2 types of candies that we're talking about, right? We're talking about chocolate truffles and caramel truffles. So we need to come up with the variable for each one of those. You guys like X's and Y's? Yeah. So let's make X our, which one? Chocolate? Truffle. And then Y would be our caramel truffle. Okay. Right. Now we can put our little system together. So we had the chocolate lovers bag. Okay. And in our chocolate lover bag, oops, sorry about that, make that a little bigger for you. In the chocolate lover bag, we have 5 chocolate truffles. So 5 chocolate truffles plus 2 caramels, so plus 2y. And that costs how much? $4.25. Yep. And then the second one we have is the combusting caramel bag. Right. And in our combusting caramel bag, we have, 8 caramels and 2 chocolates. I like to keep mine in order, my X's and Y's in order. You don't have to. I don't know. I like to be orderly, I guess. So I'm going to put my chocolate truffles first. And I ended up with, 2 chocolate truffles. So that would be 2x plus my, 8? Yeah, 8 caramels. And altogether, that's going to cost me $3.50. Everybody good with those? All right. So now I need to solve it for x and y. And I have 2 variables, and I can't really solve it with 2 variables. I have to get down to 1 variable and then be able to plug that back into the equation to solve it for my second variable. So there's a couple different ways we can do this. We've been playing a lot around with substitution. So you can take one of the equations and solve it for x or for y, and then take that answer and plug it into the other equation. So this is where I just kind of take a moment and I just kind of do some little mental checks. Because if I look at my top equation, and if I want to solve it for x, to get x all by itself, I ultimately have to divide by 5, right? In some part of my problem. So I look at it and I'm like, well, I know I got to subtract the 2y over, but then I'm going to have to divide it by 5. And 2 divided by 5 is going to give me a decimal or a fraction, right? Not necessarily my best friend. And well, what if I wanted to solve it for y, right? Oops, sometimes these. Well, if I want to solve it for y, at some point in my equation, I'm going to have to divide by that 2. And the same thing's going to happen. I'm going to have 5 over 2, which is going to give me a decimal or a fraction. And it's not a bad thing, but sometimes it makes things a little messy, right? So if I looked at my second equation, I'm like, well, if I wanted to solve it for x, I'd have to divide everything by 2. This divides by 2, of course. This divides by 2, and this divides by 2. So that's one way you could do it. You could solve it for x, and then whatever you get for x, you're going to take that and plug it in, into the x up here and solve it for y, right? But there's another method you could do as well, and it's called the elimination method. You guys want to learn how to eliminate? Uh-oh, I think I need to plug this guy in real quick. It would be a sad day if we had to end the notes early on a Friday, right? There we go. All right. So when it comes to elimination, you're going to take your two equations and you're going to write them on top of each other to start with. So I'm going to have my 5x plus, whoops, I'm going to squeeze this over a little bit, sorry. 5x plus 2y equals $4.25. And then right under it, I have my 2x plus 8y equals $3.50, right? So ultimately, I'm going to try and add these two equations together. But when I add these two equations together, I want to be able to get rid of either my x or my y. And right now, if I add these two together, neither one of them are going to go away. So I got to pick which one I want to get rid of. So just for the fun of it, I'm going to look at my y's. And I'm trying to get my y's to be like the opposite of each other. So if one of them is a positive 8, the other one is a negative 8. So when I add them together, they go away, right? So I already have an 8 in the bottom. So is there any way I could turn this into a negative 8? Multiply by negative 4. And what am I going to multiply negative 4 by? Everything, right? Because remember, when it comes to an equation, you can do anything you want to any equation. You just have to make sure you do it to everything, right? Both sides and everything. So I'm going to take this whole entire equation and I'm going to multiply it by negative 4. Right? So now I'm going to have, oh, I might run out of room. Oh, boy. Should I try it? I'm going to try it. So I'm going to have negative 20x minus 8y equals, what, negative 17? You guys always got to check my math. I screw it up a lot, right? Everybody good on that one? Yep. So, and then my bottom one, I'm just going to leave it exactly the same. So I got 2x plus 8y equals 350. And then I'm going to add these two equations together. So I'm going to get negative 18x, negative 8y plus 8y. Those are going to go away. And that's going to equal, what, negative 1350? Since we're talking about money, we're going to keep that 0 on there. And I'm going to divide by negative 18. So negative 13.5 divided by negative 18. It's going to give me 0.75. So what does that tell us? Yep, and what's our x? Yep, that's our chocolate truffles, right? So our chocolate truffles are going to cost us 75 cents a piece. Okay. Are we done? No. What do we got to find now? We got to find our y, our caramel truffles. How are we going to find our y? Anybody got any ideas? Yeah, you know what x is, so you're just going to go back to one of those original equations and plug it in. And then you get to pick. Do you want the green one or the blue one? Green. We'll go green. Yep. So if I go with my green one, oops, I have 5. And then for x, I'm going to put in my value that I found. 0.75 plus 2y equals 4.25. So we're going to get 3.75 plus 2y equals 4.25. Subtract $3.75 from both sides. We get 2y equals 50 cents. And what's half of 50 cents? 25 cents, yep. So how much does a caramel truffle cost? 25 cents. Okay.